Tell me the truth. You probably think that Earth's magnetic field is caused by a big ball of solid iron in the middle of the planet, right? Yep, I mean the inner core. But the problem here is that in the inner core, the temperatures are so high that the very magnetism of iron itself is changed. Once such a temperature, which is called the Curie point, is reached, atoms aren't able to align to a magnetic point anymore. So, in reality, Earth's magnetic field is created by the swirling outer core, and magnetism there is more than 50 times greater than it is on the surface. The liquid iron in the outer core conducts electricity perfectly, which helps it create electrical currents driving the magnetic field. Without it, our planet wouldn't be able to hold onto its atmosphere. As a result, we'd lose our main protection from extremely dangerous space radiation. But it wasn't the outer core that surprised us not so long ago. Scientists say Earth's inner core has likely stopped rotating relative to the mantle and the surface of the planet. Even more exciting, it could even go into reverse. But let's look into the details. Earth is formed of the crust, mantle, and outer and inner cores. The solid inner core is about 3,200 miles below the crust. It's separated from the semi-solid mantle by the liquid outer core. Yep, the one thanks to which we have the magnetic field. And since this outer core is liquid, it allows the inner core to rotate at a speed different from the speed of our planet's rotation. Earth's core has a radius of 2,200 miles and is almost as large as Mars. It mostly consists of iron and nickel and makes up around 1/3 of Earth's mass. The spin of the inner core is powered by the outer core. It turns out that the slowing of the core started in 2009. Since that time, seismic records, which had previously been changing continuously, have shown little difference. And it makes scientists conclude that the inner core's rotation has paused. But we're nowhere near the scenario of a disaster movie. Apparently, the inner core taking a temporary break is part of its 70-year-long cycle. During this cycle, the core switches directions every 35 years or so. This might influence Earth's magnetic field and the length of the day, but some researchers are skeptical about it. And some scientists even go as far to say that the inner core isn't moving at all. Okay, but what would happen if Earth's core indeed stopped rotating? Well, if it was the solid inner core, the answer would be nothing dramatic. Even if it didn't just reverse the direction of its movement, like it's doing at the moment, but stopped altogether, it would just impact the speed of Earth's rotation. It'd slow down, making our days longer. Plus, with time, it could probably degrade our planet's magnetic field, and it would be bad news. But not as bad as they would be if the outer core stopped spinning. As you already know, without this layer's rotation, Earth would have to kiss its magnetic field goodbye, and that's how the downfall of the planet would begin. Things would start getting shaky. The tectonic plates would begin to slam into each other. You know, like when you're going by bus and the driver suddenly hits the brakes and you end up flying into other unfortunate passengers? Yeah, like that. The sudden collision of tectonic plates would trigger destructive earthquakes along the plate boundaries all over the world. They would wipe buildings, bridges, and roads off the face of the Earth. Water systems, electricity, and phone lines would also be destroyed. But the worst would be yet to come. Without the protective magnetic field, cosmic radiation would start hitting the surface of our planet. These high-energy particles coming from the sun would come in contact with oxygen and nitrogen in our atmosphere, effectively destroying our ozone layer. This would allow even more cosmic rays to reach the surface of Earth. The radiation would damage all kinds of electronic devices and disable power grids. And the consequences would be disastrous, not only for people, but for all forms of life on Earth. The stationary core would make navigating the planet more difficult. People would have to start using trail maps again, since compasses would become useless. It would also make it harder, if not impossible, for migratory animals to find their way. Birds would keep losing directions, and turtles would fail to find beaches where they used to lay eggs. Luckily, we don't need to worry about this kind of apocalyptic scenario. The planet's outer core is very unlikely to stop anytime soon, if ever. Now, do you want to find out something cool? Then listen to this. Our planet's inner core has a core of its own. Scientists have made this discovery just recently. They've learned that this core in the core could have developed around 500 million years ago as a result of some dramatic geological changes. What about other planets? Do they have the same cores as Earth? Let's look at Mars, one of our planet's closest neighbors. Its heart is the size of the Moon. It's also almost twice as dense. Scientists made this conclusion after they got some data about the first observed Marsquake and meteorite impact. Both these events were captured by NASA's InSight lander, which had been monitoring seismic activity on the red planet for 4 years. The researchers also estimated that Mars's core is probably made mostly of a liquid iron alloy with a smattering of hydrogen, oxygen, and carbon. One day, Mars probably had a nice rotating core that supported the planet's magnetic field. There could be warm oceans swarming with life. But then, something must have happened, and on one terrible day, the red planet's core froze in place. It could have led to the weakening of Mars's once strong magnetic field. Its atmosphere was taken away by powerful solar winds, hitting the planet at a speed of several hundred miles per hour, and the red planet turned into a lifeless, dry desert. Now, what about gas giants? Let's take the largest and the most massive planet in the solar system, Jupiter. It's twice as massive as all other planets of the solar system combined. Almost 1,300 Earths could fit into this huge thing. Jupiter also has the shortest day in the solar system. It lasts a mere 10 Earth hours. At the same time, the gas giant needs 12 Earth years to complete an orbit around the Sun. Jupiter most likely appeared at the same time when the rest of our solar system formed, about 4.5 billion years ago. Probably the coolest thing about this gas giant is that it has the same ingredients as a star. But unfortunately, or should I say luckily, it hasn't grown massive enough to ignite. Scientists don't know for sure what Jupiter's core looks like. According to most theories, the gas giant has a dense core made up of heavy elements. During its formation, it was probably a collection of debris, icy material, and other small objects like comets and asteroids zipping around. Thanks to their mutual gravity, these bits of matter clumped together, forming larger chunks which later turned into Jupiter's core. At one point, it became massive enough to start attracting hydrogen and helium. More and more gases accumulated around the core until what we today know as Jupiter appeared. There's also a possibility that Jupiter doesn't have a core at all, or it might have existed once, but since then, it's eroded away. Hopefully, we'll find out the answers to these questions soon enough, since Juno, NASA's space probe, is orbiting Jupiter, collecting data about its gravitational and magnetic fields. So, what about the gas giant's magnetic field, you may ask? Does it even exist? Oh, don't worry. Jupiter is surrounded by a ginormous magnetic field called the magnetosphere.
Imagine that the rotation of the Earth will stop one day, and tomorrow will no longer come. Life will never be the same again. Normally, our planet rotates every 24 hours at a speed of 1040 miles per hour. It's faster than the speed of sound. We don't feel it while it's spinning, but we will feel it when the Earth suddenly stops. All people, houses, cars, ships, roads, trees, animals, the topsoil, everything that is not attached to bedrock, will fly away to the east. Hurricanes and tsunamis will appear. Endless today brings huge global earthquakes, and volcanoes will wake up and start erupting, threatening to destroy everything. After the global shutdown, The water on Earth united into two oceans, the North and the South, and all the continents became one, connected at the equator. Now there will be eternal day on one side of the planet, eternal night on the other. Unbearable heat is replaced by terrible cold. On this side of the planet, all nature freezes over, and the night never ends. It will be very difficult to move around and get food. There will be nothing but desert on the bright side of the planet. The temperature is so high that it is impossible to farm here. But there is one area. Ideal living conditions have been created on the border between the hot and cold halves, places where you can watch an endless sunset or sunrise. The biorhythms of all surviving creatures will be disrupted due to a long bright day and a long dark night. This will affect your psychological and physical development. Life in this zone will not be better for a long time. The temperature drops very quickly and it gets colder and darker outside. This is because the Earth is slowly rotating around the Sun and the boundaries are shifting. The survivors will have to constantly move to stay in this area. The shape of the Earth will change and will become perfectly round. The world's oceans are changing again. Floods are inevitable. The problems will not end there. The old magnetic field worked due to the rotation of the Earth, protected us from solar winds, ultraviolet radiation, and radiation from the depths of space. Now he's gone. Without it, existence on the surface of the planet is impossible. The only way to survive is to go underground. People will have to dig tunnels, build underground cities, and go to the surface only in special protective suits. But there's nothing left. No plants, no trees, no animals. Survivors will have to set up water purification, electricity generation, air filtration, and adapt plants and animals to life without the sun. At first, people will eat mushrooms. But things could have been even worse if the Earth had stopped completely. If the Earth stops orbiting the sun's gravity will pull our planet so fast that people won't have time to evacuate. Normally, our planet's rotation around the sun is like riding a fast merry-go-round. You can't get close to the center because of the high speed. In this case, there is no hiding underground. Well, I hope humanity will never see this scenario and we will continue to spin on our cozy blue ball.
Whoa, something doesn't feel right. Everything seems shaky. It's definitely not an earthquake, and it's actually getting worse. The clouds seem to move quicker than usual, and the animals are going into a frenzy. The news anchor pops up on the TV in an alarmed tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second, and they don't know why. Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kind of makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there will be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse. feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function, and mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds, but around the equator you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stop, since the radar systems have gone haywire and the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually we'll have a total communication blackout. Ships will cease to operate and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will now be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be in danger, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we'd probably feel like we're always on a jet plane going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day. So days would be around 7 hours long as well as nights. The whole world would be flooded, except for the highest points and the tallest mountains. If that happens, humans will most likely end up there clinging to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters like earthquakes, tsunamis, volcanoes, and even melting ice sheets have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour, and as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture, since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded, and the crust will be 80% gone. If it goes on any longer, there won't be any living things around, probably except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted. And with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the Moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the Moon's gravitational pull on our little blue planet. It'll most likely go on that way. So hey, what's your hurry? You know, rotation is a funny thing. Not haha funny, but kinda strange. Not only can't you feel it, everything does it. From galaxies to atoms, the universe is taking us for a spin. Strangely, it was more difficult to prove that the Earth is rotating than it was to prove that the Earth is revolving around the Sun. Way back in 1610, Galileo, the father of experimental science, provided the first proof that Earth, and all the other planets, revolve around the Sun. Galileo showed in his telescope that Venus was going through phases like the Moon. The only conclusion possible was that Venus was revolving around the Sun. Case closed. Planets revolve. But it wasn't until 241 years later, March 31, 1851 to be exact, that Leon Foucault proved that Earth was rotating. Foucault installed a giant pendulum from the 220-foot-high ceiling of the Pantheon in Paris. That's a lot of peace. An assembly of scientists and journalists watched as the floor turned beneath the giant pendulum. "The Earth turns," they shouted, mostly in French. Another strange thing about rotation is that although the Earth is rotating at a constant speed, the surface of the Earth is moving at all different speeds at all different latitudes. The same is true for every planet and star. At the equator, the surface of the Earth is moving the fastest at 1,037 miles per hour. That's much faster than the speed of sound, which is a mere 761 miles per hour. Halfway from the equator to the North or South Pole, at 45 degrees latitude, the Earth is rotating at 733 miles per hour. Standing at the North or South Pole, it would take you 24 hours just to turn around one time, and that's both boring and cold. One result of these differential rotational speeds of Earth is that it creates belts and bands not only in the atmosphere, but also on the surface of the Earth. Jupiter, of course, is famous for the belts and bands in its clouds caused by the giant planet's rapid rotation of about 28,000 miles per hour. The belts and bands on Earth's surface are somewhat overlooked, but we've got them too. We have white ice at the North and South Poles, and between the two poles, there are alternating belts and bands of dry sandy desert and moist green vegetation. This essential geography can be seen most clearly when we view the Earth rotating in space. Space agencies use the differential rotation of the Earth to their advantage. They launch their rockets as close to the equator as possible. NASA uses Cape Canaveral near the southern tip of Florida. And the ESA, the European Space Agency, uses the Guiana Space Center in French Guiana, South America, almost exactly at the equator. Because the land under a rocket near the equator is rotating at a greater speed, it gives the rocket a boost into space that launch sites near the poles cannot provide. You always want to save fuel, you know. Speaking of Jupiter, as I did about 3 paragraphs ago, the axis of rotation of the big planet is even less inclined than that of the Sun. The Sun is tilted at an angle of around 6 degrees, while Jupiter is only tilted 3 degrees. Jupiter stands almost perfectly upright, which combined with the great speed at which Jupiter is rotating, its entire day is less than 10 hours, it turns Jupiter into a giant gyroscope. Jupiter's gyroscopic stability, combined with its massive gravity, gives stability to the whole solar system. Jupiter prevents chaos factors from disrupting the orbits of the other planets. In other words, without Jupiter rotating like a stable gyroscope, the solar system could never have stayed intact for the billions of years that it has. Exoplanet solar systems are showing signs of chaos in their orbits. They could use a gyroscope like Jupiter to hold them together. Rotation is the real hero here. As for the Sun, its differential rotation has a big effect on its sunspot activity. Sunspots are spots or patches that sometimes appear on the Sun's surface, usually at mid-latitudes in both the northern and southern hemispheres of the Sun. As sunspot activity increases on the Sun, sunspots begin to move closer to the equator. Few sunspots are ever seen near the poles. With differential rotation, the gases at the equator of the Sun are moving faster than the gases at the Sun's poles. This differential motion of the gases twists the magnetic field lines in the Sun, causing them to snap. Sunspots are magnetic eruptions rising through the surface of the Sun, hurling electrified gases far into space and emitting intense ultraviolet radiation, often in the direction of the Earth. Uh-oh. Well, have no fear, Earth's differential rotation protects us. Not only does our Earth rotate differentially on its surface, but also down into its center. Studies of seismic readings of shock waves from earthquakes indicate the metallic core of the Earth is rotating slightly faster than the surface of our planet. Scientists think that the differential rotation of Earth's magnetic core within the slower rotating metallic liquid creates the magnetosphere arising from Earth's poles and extending far out into space. This magnetosphere keeps Earth safe from electrified gases from the Sun. Hurrah for rotation! Far out! Now, the 9.0 megaquake in 2011 off the coast of Japan rearranged the mass of Earth's crust and caused the rotation of Earth to speed up. The day got shorter. Not much shorter, 1.6 millionths of a second, but we are accustomed to seeing the Earth's rotation slowing down. The Earth rotating through the tidal action of the Moon's gravitational effect on the oceans drains kinetic energy from the Earth's rotation, causing the planet to slow down. Each day is becoming longer, about 0.02 of a second longer. Well, I need to adjust my watch. Leap years, we all know, are when we add a day to the calendar every 4 years, on February 29th, to straighten up Earth's yearly rotation around the Sun, taking 365 1/4 days. But leap seconds are added to the clocks every so often to synchronize our clocks with the slowing rotation of the Earth, and allow the Earth to catch up with our clocks, as if the Earth is concerned about our timepieces. 27 leap seconds have been added since 1972. The last leap second was added on December 31, 2016, and made the clocks read 6:59:60 p.m. Yeah, I didn't notice either. But the Sun's rotation has unexpectedly been speeding up recently. Usually it takes 86,400 seconds for the Earth to rotate, as measured by an array of atomic clocks in different locations on Earth and coordinated by a special service in Paris. Yes, they pay people for that. July 19, 2020 was the shortest day ever recorded, a whopping 1.46 milliseconds less than the usual 86,400. Gadzooks! If this keeps up for another 5 years, they may have to add a negative leap second to synchronize our clocks to Earth's increasing rotation. Computers and satellites won't like to see their clocks read January 1st at 0 o'clock, and they say time can't go backward. At least the Earth hasn't started rotating backward or stopped rotating altogether. That would be catastrophic. Everything would crash forward at whatever differential speed it was rotating on Earth. Yet that appears to be what happened to the planet closest to Earth, Venus. Venus rotates very slowly backward, in retrograde, and that is very unusual. How so, you ask? Well, there are several theories to why Venus rotates in retrograde motion, while all the other planets rotate in prograde or forward motion. Liquids inside a rotating sphere, like a planet, have a lot of inertia. That's why when you take an egg from the fridge, for example, and try to spin it, it won't spin. The liquid inside is just sitting there. Its inertia is resisting your attempt to spin it. However, if finally, after many turns, you manage to get the raw egg to rotate, it's hard to get it to stop spinning. If you do pick it up and put it back down, the egg will start rotating again, because the inertia of the liquid inside it is still going forward. you only stop the shell from spinning. Something like this may have happened to Venus. Wait a minute. Venus? Backspin? Tennis? I think there's a connection here somewhere. We know that on Venus, the planet, one day is longer than 1 year. It takes longer for Venus to slowly rotate around backward one time than it takes Venus to orbit the Sun once. But Venus is slowing down dramatically, and by 6.5 minutes in the last 25 years. If there still is liquid inside Venus and the movement continues, we might see Venus completely stop spinning backward and start rotating forward again. Come on, Venus, let's get with the crowd. This business of retrograde and prograde rotation has got quite a bit of mystery to it. It seems that everything tends to rotate in prograde motion. If you shape your right hand like a ball and stick your thumb up to indicate north, then curl your wrist towards you, that's prograde motion. Your fingers on the left side of your hand are moving towards you. Black holes, solar systems, galaxies, atoms, stars, etc. all seem to rotate prograde, depending on which angle you view them from. Experiments at the Large Hadron Collider indicate that subatomic particles spin toward the left, prograde. It's starting to look as if we may be in a left-handed universe. Then why is it so hard to find a left-handed manual can opener or measuring tape? I don't know. It's a mystery. Every April, a group of scientists observes the faint glow of asteroids passing by our planet. One year, they realized there was something weird shimmering in their telescopes. The team expected it to be another asteroid, but they ended up very surprised because what they discovered was an unusual space rock that didn't consist of the minerals that usually make up asteroids. It was made of silicate, the material mostly found on the Moon. They named it Kamo'aliwa, which is a Hawaiian word that means wobbling celestial object. The rock didn't match any near-Earth asteroid scientists had already been familiar with. Instead, that piece had a pattern of reflected light, similar to that of the moon rocks astronauts had brought back from NASA missions. This fragment turned out to be a quasi-satellite, which is a kind of asteroids that orbit both our planet and the Sun. It repeatedly circles Earth and has a quite unusual tilt. That's the reason you can only see it in the night sky once a year. The fragment is pretty shy, too. It never gets closer to our planet than 9 million miles. That's almost 40 times as far away as the Moon. Plus, this space body often hides in the shadows. Scientists have figured out the piece won't stay in this orbit for a long time. It probably arrived at its current position about 500 years ago, and its orbit is likely to change in the next 300 years. This fragment may not be alone out there in space. There are at least 3 more similar near-Earth objects. They may have all come from the same place. Researchers aren't sure yet about the nature of the rock, but they can find out more about this unusual space object if they send a spacecraft to collect samples and bring them to Earth. That's something China's space agency is planning to do later this decade. Now, the Moon appeared in the middle of chaos. There are several theories about how that happened. The first one claims the Moon used to be just a wandering body, similar to an asteroid. It formed somewhere in our solar system. Once, it approached too close to Earth and got captured by our planet's gravity. The second theory says that our planet was spinning so quickly that some material broke off and started circling around it. One of the largest pieces was the Moon. The third theory says that the Moon was formed at a time when our planet was going through its own formation process. But today, the most widely accepted theory goes like this. Once, a long, long time ago, but not in a galaxy far, far away, Earth collided with a Mars-sized planet. The debris and clouds of dust from the collision gathered around our planet and started circling it. Eventually, something that we today know as the Moon formed there. Apollo missions brought more than 1/3 of a ton of soil and rock from the lunar surface. These rocks show that the Moon had mostly the same building materials as our planet. This might mean they have a common history. If the Moon had been formed somewhere else and had been eventually captured by the gravitational force of our planet, it would have a different composition. Also, if it had been created at the same time as our planet or had once broken off, there would be the same minerals on both the Moon and Earth. But the minerals on the Moon contain less water. Plus, our planet's natural satellite is rich in materials that form fast at high temperatures. Now, the Moon isn't the only space body in the solar system with a mysterious past. Hippocamp is Neptune's moon, discovered in 2013. It's the smallest moon of this ice giant, a mere 21 miles across. It's very close to Proteus, the biggest of Neptune's inner moons. And no, Hippocamp is not a place for big African mammals to spend the summer. Scientists think Hippocamp probably formed from debris after Proteus collided with a comet. If Hippocamp had entered Proteus's orbit from some other place in our solar system, the bigger moon would have either swallowed it or booted the tiny moon away. But not even Proteus itself is among the first generation of Neptune's moons. It was formed from the remains of the planet's earliest system of moons. Those first moons were destroyed when Neptune captured Triton, currently the largest of its moons. The main evidence proving the collision was likely to happen is the fact that Triton circles around Neptune backward, unlike other moons orbiting the planet. Neptune captured Triton from the Kuiper Belt. That's an area filled with icy objects and rocky debris stretching beyond Uranus. That means Hippocamp is a third-generation moon. Kinda like a second cousin twice removed or something. Now, the Sun also had a turbulent past. Our star appeared about 4.6 billion years ago. It's hard to study its early stages of life since that happened 50 million years before our planet was even formed. But recently, a team of researchers has discovered crystals that are over 4.5 billion years old. Hidden deep within meteorites, they've revealed some things about the past of our Sun. Before the planets were formed, our solar system had consisted of a central star and a massive disk of dust and hot gas spiraling around it. As the dust and gases cooled down, they turned into minerals, including the crystals found in the meteorites that landed on our planet. Those ancient materials were irradiated, unlike some younger substances. Researchers think something might have happened to the Sun after those crystals were formed. Perhaps the activity of our star was less intense then. Or maybe, for some reason, these younger materials couldn't travel to the areas where irradiation was possible. Dwarf planets give us a chance to sneak a peek into the ancient years of the solar system. Around 4 billion years ago, Jupiter's, Saturn's, and Neptune's gravitational forces joined. They sent asteroids and comets hurtling across the solar system, making them collide with different planets. All the dwarf planets from the Kuiper Belt, for example Pluto, Eris, Haumea, Makemake, have their own moons that likely formed after some powerful collisions. Icy debris in orbits similar to Haumea's, for example, can prove the theory of an ancient collision. The debris it created simply didn't have enough energy to float away from the dwarf planet's gravitational pull. Ceres, another dwarf planet, has ammonia-rich clays on its surface. Ammonia isn't stable at the temperatures prevailing on Ceres, but there's plenty of this substance in the outer solar system. It means that Ceres was probably formed in those outer parts and got kicked inward. After all, the gas giants were migrating a lot at those early stages of the solar system. Or the dwarf planet could have formed in an asteroid belt, and ammonia somehow, let's say after a powerful impact, appeared on the dwarf planet. Ceres might help scientists understand icy moons better. The ocean floor on Earth has a high concentration of carbonate minerals, and some parts of Ceres have them too. This means this dwarf planet is like some sort of fossilized ocean world. Many exoplanets, a term used for planets outside the solar system, have also gone through pretty intense collisions in their early stages. This double star system is more than 300 light-years away from us, and its stars are at least 1 billion years old. Even though it's not young, this system still shows some signs of swirling clouds of dusty debris that haven't cooled down yet, which isn't something you'd expect from a star system of this age. This debris is still warm. It means there might have been a strong collision of two planets or some other space bodies of similar size in that region, and relatively recently. So hey, everybody just simmer down. Dust particles circle around a young star. They stick together and grow bigger with time. That's how planets form. The leftover dust often settles in some distant cold areas. An example in our solar system is the Kuiper Belt. It's located far away beyond Neptune. As solar systems evolve, those particles keep colliding until they're so small they end up being pulled into nearby stars or kicked out of the system. Uranus spins on its side if you compare it with the rest of the planets in our solar system, and the only way we can explain it is a powerful collision in the past. Something much bigger than a regular comet or some other space body of similar size likely hit Uranus and knocked the planet on the side. It was probably a planet twice the size of Earth. It could be a protoplanet. This is a space body made up mostly of ice and rock that orbits a star and is likely to develop into a planet sometime in the future. Anyway, the fallout from the impact smothered the core of Uranus. It prevented the heat inside the planet from escaping. This might explain why Uranus has extremely cold temperatures on its surface. Man, bring a jacket and a blanket. So get this, the Earth acquires 40,000 tons of mass every single year. More and more people are being born, new buildings and structures. You might think that's something that adds mass, but nope. Since it's created out of existing matter on the Earth, it's actually dust falling from space to our planet. That dust consists of vestiges coming from our solar system, like space bodies that never managed to form into a planet, or asteroids and meteors that fell apart on their way and now drifting around. Our planet is there like a giant vacuum cleaner that pulls in all those particles of dust powered by gravity. So yes, Earth gains weight, but some calculations also say the entire planet, including the atmosphere and the sea, is losing around 50,000 metric tons of its mass annually. Gases like hydrogen and helium are within our planet's atmosphere, but they're so light gravity can't retain them there. So huge amounts of those gases escape our planet every year. 6 pounds of hydrogen every second. Sounds like a lot, but the Earth is really heavy, so it would take trillions of years for all the hydrogen to escape our atmosphere. Also, the planet's core is like some sort of big nuclear reactor. It runs all the time, so it gradually loses energy, which means it's losing mass too. Our planet is not a perfectly shaped sphere, it's more like a squashed one. As it spins, gravity is directed toward the Earth's center, while a centrifugal force goes outward. Earth has a tilted axis, so centrifugal force doesn't exactly oppose gravity. Also, gravity pushes those extra masses of Earth and water up at the equator into a bulge. Earth also has a waistline, 24,900 miles. You weigh more standing at one of the poles than at the equator. Although, for weight loss, Pluto comes as the best option. A 150-pound person would weigh around 10 pounds there. Avoid Jupiter, the same person would weigh over 350 pounds there. Our planet is all green and blue now, but chances are it used to be purple. Scientists think ancient microbes might have used some other molecule to harness the sunlight instead of chlorophyll that gives plants their green color. That molecule possibly colored the living organisms into a more violet shade. The Earth is electric. Just one stroke of lightning can heat the air to over 50,000 degrees Fahrenheit, which causes the air to rapidly expand. That same ballooning air makes a shock wave we know as thunder. 6,000 lightning flashes appear all over the planet every minute, and the longest one occurred in the sky above Brazil, 440 miles long. Newer studies found out that the Earth's core is as hot as the Sun's surface, over 9,300 degrees. The driest spot we have is the Atacama Desert of Peru and Chile. The center of Atacama has spots where we've never recorded any rain. The coldest place is naturally Antarctica, where winter temperatures can go down to minus 100 degrees Fahrenheit. No thanks. It's also the biggest desert we have on Earth. We imagine deserts as endless, sandy, and insanely hot areas, but there are coastal, subtropical, and polar deserts. They all have windswept and barren lands, which makes them very difficult for animals and plants to inhabit. The Pacific Ocean is the Earth's biggest ocean basin, which covers a huge area of almost 80 million square miles. The Pacific contains over half of the free water on our planet, and is so big all of our continents could fit there. Earth used to have 2 moons, or at least that's something scientists believe. That second one was almost 3 times smaller than the one we have today, and may have orbited our planet before it slammed into the bigger one. This clash may be an explanation of why the 2 sides of the moon we're left with is not equal. And there are moonquakes going on. It looks pretty inactive from our perspective, but the ground there is definitely shaking, although less than on Earth. Moonquakes shake at great depths, especially midway between the lunar center and its surface. To get to the longest mountain chain, we have to look way down under the surface of the Atlantic Ocean. It's a chain of volcanoes that goes about 18,000 feet above the bottom and spans over 40,000 miles. We have a magnificent planet, more than 4.5 billion years old, which makes it 10,000 times older than humans. But it's not the same as it was in the beginning. The ground we walk on is recycled. Earth has its cycle. Magma from the depths of our planet comes up and hardens into rocky matter. Tectonic movements brings the rock to the surface where erosion happens. That's a process where wind, water, and other natural forces break apart rock and changes it. The small pieces get buried, deposited, and compacted into sedimentary rocks like sandstone. If these rocks are buried deep enough, they get cooked and transformed into magma. So the whole cycle repeats all over again. We got used to seeing lava and ash coming out of volcanoes, but some of them even produce their own flashes of lightning. In 2020, the Tal volcano, which is around 40 miles away from the Philippines' capital, Manila, started blasting smoke and ash pretty high into the air. Inside its ash column, small pieces were colliding and then producing lightning flashes people could see scattering across the sky. Lakes can go crazy and explode too. Neos, Manoon, and Kivu are 3 lakes that sit above volcanoes. Since there's magma under their surface, there's carbon dioxide released into the lakes, which leads to a deep gas layer above the lake bed. It's pretty rare, but carbon dioxide can suddenly erupt from the lake and form an unpleasant gas cloud, similar to something a volcano does. 70% of our planet's surface is covered in oceans, but we've only explored 5% of them. And around 300 million years ago, I wasn't around then, we only had one massive supercontinent called Pangaea, with one huge sea, Panthalassa. Surprisingly, coral reefs are the biggest living structures. They consist of small coral polyps, but together they make a true community of organisms and a very important part of Earth's ecosystem. Some coral structures can even be seen from space. The Earth's surface is not evenly shaped, which means mass is uneven too. That way, gravity is not the same in all spots on Earth. There's a mysterious anomaly in the Hudson Bay of Canada. The gravity there is lower than in other regions surrounding this area, and scientists believe it's because of melted glaciers. During the last ice age, that region was covered in ice, which is now long gone and melted. But the planet hasn't completely recovered from the icy burden. Gravity over any area is proportional to its mass. The glacier left an imprint that pushed aside a part of the planet's mass, which is one of the reasons why the gravity is weaker in that area. Some bugs get nastier when in space, without gravity. Studies showed some bacteria, like Salmonella, can make worse damage in space because there's something in the lack of gravity that makes them tougher and changes their activity. The days on Earth are slowly getting longer. When the planet was formed, days were about 6 hours long and gradually got longer. 620 million years ago, a day lasted 22 hours. Today, we have 24 hours, but it's increasing by around 1.7 milliseconds every century. This happens because of the Moon. It's slowing down our planet's rotation with the tides it helps create. When the Earth is spinning, tidal ocean bulges are pulled a little bit ahead of the Moon-Earth axis. That makes some sort of force that slows down the rotation of our planet, which is how our days are getting longer, but really slowly. We'll have to stick to our 24-hour schedule for a very, very long time. Earth's core certainly seems to be far away from us, but the distance is not that big, 1,800 miles. That's shorter than Route 66. The strongest earthquake we ever had was in Chile, a magnitude 9.5. If an earthquake ever reached magnitude 12, it could split our planet in half. Also, if there's an earthquake happening, it can hit more than 400 miles under the surface, which is why people on the other side of the planet can literally feel that. Our planet has around 100 million times more individual viruses than there are stars in the universe. Clouds are not some fluffy things whose shapes we sometimes like to watch. They actually help regulate the temperature of Earth. If we could pull out all water droplets in clouds and bring them to the surface, that would cover the planet with a liquid film as thick as a human hair. And yet, such a small amount of water brings enough differences with the weather and climate. Our planet would be 13 degrees hotter if it weren't for clouds. A super-Earth, ready to be explored, is floating in space relatively close to us. a mere 337 light-years away from our planet. The term super-Earth is used to describe a planet beyond the solar system, with a mass higher than that of Earth, but below those of the ice giants of the solar system, Uranus and Neptune. Their masses are 14.5 and 17 times that of our planet, respectively. The term also refers only to the mass of the planet, not its habitability or surface conditions. But the coolest thing about this newly discovered super-Earth is that it might harbor a second, Earth-sized planet. The bigger planet is dubbed TOI 715b. It orbits within the conservative habitable zone of its parent star. Moving within this region means there might be liquid water on the planet's surface. Of course, several other factors need to line up for the surface water to appear. But the conservative habitable zone, unlike the optimistic habitable zone, makes the planet a great candidate for harboring water. As for the smaller planet, it's likely to be just a bit larger than Earth, and it might also dwell inside the conservative habitable zone. NASA's James Webb Space Telescope, as well as other new spaceborne instruments, are designed not only to detect distant worlds, but also to reveal some of their main features, including the composition of their atmospheres. And based on this knowledge, we can get clues to the possible presence of life there. The newly discovered super-Earth, TOI 715, orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within the star's habitable zone. Tighter orbits also mean that planets cross the faces of their stars more often. In the case of TOI 715b, it's once every 19 days. That's how long a year in this mysterious distant world lasts. Star-crossing, or transiting, planets can be detected more easily and observed more frequently. And it's great for TESS, the Transiting Exoplanet Survey satellite, which found the new planet. This satellite has been adding to a long list of habitable zone exoplanets since its launch in 2018. Unfortunately, observing such transits for Earth-sized planets moving around Sun-like stars is beyond the capability of the space telescopes we have today. Plus, it takes too long, an entire year, to wait for a new transit. Planet TOI 175b is now on the list of habitable zone planets that can be examined more closely by the James Webb Telescope. Who knows? Maybe this awesome instrument will spot signs of an atmosphere surrounding the planet. Its presence, or absence, will depend on other properties of the planet, like its mass and size. Also, we need to figure out whether it can be classified as a water world. If it is, then its atmosphere, if present, will be more prominent and less difficult to detect than that of a more massive, drier, and denser planet, likely to keep its low-profile atmosphere close to the surface. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to figure out the planet's mass. Once they do it, they'll likely know whether TOI 715b is a watery terrestrial planet. By the way, if the second, yet unconfirmed Earth-sized planet turns out to be real, it will be the smallest habitable zone planet ever discovered by TESS. At the moment, James Webb is our best bet for observing the characteristics of these faraway worlds. But in the coming years, the next generation of ground-based, extremely large telescopes will be able to peer deeper into space, looking for new exoplanets.
We have found out quite a lot of things about the past of our planet, but can we figure out its future? And I mean, not guess or predict, but estimate scientifically. Before we move on to assessing the future of our planet, I suggest we define the future of our channel. Please support our work by subscribing and liking. Thank you. Well, experts think we might learn more about the future of Earth with the help of a few long-term factors. Among them, we've got the rate at which the interior of our planet is cooling, the chemistry at Earth's surface, and even the way our planet gravitationally interacts with other objects in the solar system. And don't forget that we humans also cause serious changes to our home planet. For example, take climate engineering and other technologies. Some people even believe that technology might be what will lead humanity to extinction. If it ever happens, the planet will begin to evolve naturally and much more slowly. Experts think that over periods of hundreds of millions of years, certain space invaders can lead to mass extinctions on Earth. I mean, comets and asteroids that might crash into our beautiful blue world at one point in the future. Another threat from space can be a powerful near-Earth supernova. It is a gigantic explosion, the largest in space, and it unleashes enormous amounts of energy. The temperature at the core of a supernova is often 6,000 times higher than that in the Sun's core. It can reach several billion degrees F within microseconds. After that, atoms get crammed together so infinitely close that the squeezed core recoils and the star explodes, creating a superheated shock wave. If a supernova ever occurred around 30 light-years away from Earth, we'd have huge problems. An incredibly powerful blast of radiation would bring a massive influx of high-energy neutrinos. Our planet would be vaporized in just a fraction of a second. Even the shock wave would have enough force to wipe out our oceans and the entire atmosphere of our planet. Another prediction says that while the Sun is orbiting the Milky Way, stray stars may approach our solar system. They can get close enough to have a disastrous influence on our planet. Such an encounter can also lead to comets in the Oort clouds becoming more active. The Oort cloud is a region of space filled with icy celestial bodies, orbiting within half a light-year away from the Sun. And if something, for example, a wandering star destabilizes this region, the number of comets reaching the inner solar system and US will likely increase 40-fold. But while scientists can't be sure about asteroid impacts or supernova explosions, they can forecast large-scale geological events. One theory claims that Earth will continue to experience glacial periods for quite some time. Also, the movement of tectonic plates will probably result in the appearance of a new supercontinent. It might happen in 250, 300 million years from now. The changes in the luminosity of the Sun, which will become brighter and brighter, will lead to an increased level of solar radiation reaching Earth. It will eventually cause a drop in the level of carbon dioxide in the atmosphere around 600 million years from now. If this tendency continues, plant life will disappear from the face of the Earth. Of course, it will also influence animal life, since plants are the base of the animal food chain on our planet. In 10 billion years or so, the luminosity of the Sun will become 10% higher than it is now. It will turn the atmosphere of the planet into a moist greenhouse. The oceans will start to evaporate. In around 2-3 billion years, the planet's magnetic field might stop functioning. 4 billion years from now, a rise in Earth's surface temperature will lead to conditions resembling present-day Venus. By that point, there won't be any life left on the planet. And finally, the Sun will most probably absorb Earth in around 7.5 billion years. It will happen after our star enters its red giant phase and expands way beyond the current orbit of our planet.
You wake up with a start, open your eyes, and look around. Oh, you're inside your sleeping capsule. Its walls are littered with different buttons and tiny screens. You press one of them, and one of the sliding panels sweeps to the side. You crawl out of your pod and start another regular day on the moon. Or maybe you open your eyes and come up to the window to have a look at the weather outside. Everything seems to be as usual: blue trees, purple sky, and low-hanging yellowish clouds. Great, you won't need your acid rain protection today. Or maybe you'll open your eyes to the dry plains of the red planet. You'll eat your 3D printed breakfast and set off on a trip to Olympus Mons, the largest volcano on Mars.
You've been planning this climb for ages. Whatever scenario it is, one thing is glaringly clear. You're not living on Earth. Why? There might be a few reasons why people could have abandoned our beautiful green paradise. The sun might have grown too old and started to expand, burning vegetation, boiling the oceans, and leaving Earth uninhabitable. Or it was probably a collision with the Andromeda Galaxy. Yes, the one that is bound to crash into the Milky Way in about 4.5 billion years. It could have been a wandering asteroid large enough to destroy all kinds of life on our planet. Of course, these days, astronomers have their own ways of spotting such space intruders. But what if their equipment malfunctioned? It would end badly for Earth and Earthlings. A much sadder reason for us to leave our beloved planet would be our own actions and the risks we pose to it. According to statistics, these days, the onslaught of droughts, earthquakes, floods, and epic storms is triple the number from the 1980s and almost 54 times that of 1901. Climate change could lead to water shortages, a severe lack of food, and the submersion of coastal regions. If it all went too far, we'd have to conserve the planet to save at least some of its flora and fauna. Then, it would become a nature reserve the remaining people would sometimes visit. But if not on Earth, where would humanity live? Surprisingly, there are quite a few options. For example, we could dig several feet beneath the surface of the moon and build our bases there. Or the first towns on the moon might be built in craters and covered with protective materials, like plastic reinforced with a net made of titanium and UV-resistant superfiber. The inhabitants would have to access their homes through airlock entrances dug into a mound. Or we could skip the moon altogether and set off towards the moons of Jupiter, Saturn, Uranus, or Neptune. Yes, they're much farther from the sun and probably way too cold for us. But on the bright side, these moons are believed to contain vast amounts of water, carbon, and nitrogen. And still, the most likely destination is Mars. Unlike the moon, which has a very, very weak atmosphere that consists of unusual gases, Mars has a bit denser atmosphere, even though it's still about 100 times less dense than the atmosphere of our home planet. In any case, it can offer us some protection against harmful space radiation. Mars also has about 40% of Earth's gravity, which is not that bad. We could probably get used to it with time. Plus, there's water ice on the red planet. The soil there contains enough carbon to grow plants. With time, the planet could be terraformed with the help of water from underground ice or imported from an ice asteroid. We'd use this water to form a thin ocean and maybe even create a breathable atmosphere. Or we could find an exoplanet that has all the resources to support life. An exoplanet is a planet outside our solar system. It would probably be much easier for us to find a world that would be perfect for us, rather than reconstruct the already existing world with its own workings.